Hi everyone, my name is Balaji. Currently, I'm pursuing my BTech in Computer Science and Engineering with a specialization of Artificial Intelligence and Machine Learning in the Organization Institute of Aeronautical Engineering, Dundigal, Hyderabad. And as per my topic of AET2 Tech Talks, my topic is about parking lot management and the subject essentials of problem solving. Here, we can know how to manage a problem uh, on the problem managing the parking slots when the vehicles or cars enter into a parking area of any shopping mall or anything where it is looks so clumsy. How can we manage it through some logics of graph theory which has to be which would be taught to us in essentials of problem solving courses in the current semester. And let's dive into the project and let's look what the code says and how can we solve this. And here in the introduction, here modern parking facilities require fast, efficient, and navigation and real-time availability to monitoring. In our daily lives, we see how much clumsy and how much trafficable the parking slots or parking areas would look to us. And also, manual parking methods fail under high traffic conditions wherever we see in our daily life, wherever we travel, wherever we work, or wherever we study, we see the basic problem of the traffic of parking your vehicles or standing alone with the vehicles. And also, graph theory offers a structured way to model the parking layout as nodes and edges. And also, this project uses graph algorithms plus object-oriented programming plus Java to optimize parking operations in a clear and structured way, which gives the perfect interaction and perfect solution to the project of this one. And diving into the project, we can see the problem definition. The what does the problem state or what is the problem definition is finding the nearest available parking spot is slow and inefficient if done manually. Navigating complex parking layouts require optimized path to reduce congestion, and also maintaining accurate spot availability in real time is challenging. There is a need for graph-driven intelligent parking allocation and routing system wherever you see, wherever you drive. You can't look where it has the space to park the vehicle, where you are concentrating more in your drive and also concentrating more on the regular spaces where you can stand your vehicle. But it is impossible in some clumsier times or in some trafficable times. And how can we overcome this problem through our new technologies in the future driven era? We can see the objectives, the model the parking layout as the graph, the containing V of E, that means vertices and edges for efficient transversal. Here we apply BFS to find the nearest free spot in Dijkstra and Dijkstra's algorithm to find shortest exit path. And also we automate spot allocations, ticketing, and path generations. And also because of this we can improve parking efficiency, reduce the time taken to park your vehicle, and also minimize the internal traffic within the particular parking slot or anything. And also when it comes to system requirements, whatever the requirement we have from the system side, they are hardware, entry of the exit sensors, cameras, digital boards, and coming to software, we can have Java, graph libraries, and adjacencies list from the Python, and for MySQL or local DB for the database management and database storage. And also functional requirements, what we need is real-time availability update, graph-based routing, ticket generation, and payment management have to be how do we also have UPS. We could be which could be more faster as compared to our past and olden days. And the coming to the next one, we can see a graph theory approach. What is the approach of graph theory towards this problem? From my point of view, no, from my side, I give parking spots, entry, exit, and intersections represented as nodes. and also lanes between them represented as edges, weighted or it may be unweighted. Mostly, it looks unweighted because the dimensions may vary. And also, BFS is used to locate nearest available parking slots. And also, we use Dijkstra's algorithm. Dijkstra's algorithm used for shortest path to existing considering distance. Whatever the vehicle enters early, it looks the shortest path and it should be parked there. This system helped in managing more of your vehicles in a more structured way to park them, and also it makes your work little much easier. And also we have now diving into the next slides, we can see here architecture of the system architecture. How did we arrange the stages in the architecture of this parking slot management, or how do we do this? You can see here user interfaces. You can make a parking controller and also a graph manager and a database system using SQLite or MyDB or a Django like that. And also you can do like a what we say graph manager stores adjacent leaks and perform BFS and digital operations on them certainly to train the models, and also parking controller updates graph when spots become occupied or free. Also database stores vehicles tickets and spots. You it's all about what you do in a structured way, also in a clean and a neat, also going with a plan helps us to work more effective in this. And also yeah, coming to this OOPS class structure, no, I have earlier said that we are using object-oriented programming in some references in some cases, and also what are we using with this class structures is we are making a class of graph. It contains adjacency list, add edging list, and also BFS list, and also digital methods, and also containing a class called parking lot. It manages spots, integrates with graph, and also parking spot class. Parking lot and parking spot means it can spot ID, it can spot wherever the parking is available when a new vehicle enters, and also shows about the neighbors, and also vehicle classes, vehicle no type, vehicle number, its type, its ownerism or ticket class, entry time, exit time, fee calculation, how much time it is this particular time, particular amount, and also payment classes, process payment, generate receipts, and etc. Much more, and we can use. I think we can introduce more into this, but simple model project I have been stopped with it, and also UML diagram. It shows the relations, parking lot, parking spot, and also parking lot graphs, and also graph for nodes and edges, and also vehicle ticket and payment. If you guys want it, um, I can, I will keep my project report which contains all the codes and all the objectives of this project in the description. You please check out there, and also graph representation. How we do represent the graphs in this problem. Graph stores in adjacency list, and also nodes is called parking spots and enter gate and exit gate. Edges represent paths, weights represent distances, and also dynamic update when spot status changes. And coming more about to know about this, we can Java implementation. How we implementing Java into it? Display snippets, graph class, BFS function, digital functions, spot allocation flow, and etc. Also, main program flow we can use user enters, then system runs BFS and gives the nearest free node return and gives the edge for it, and also user parks a ticket generated automatically, and on exit digital generates shortest exit route time, and also payment processed spot freed and graph updated. Oh, how nice it is. And also complexity analysis, what complexity is, in well using BFS, vertices plus edges may get consequences, and also digitals may get the same consequences in logging E, and also the route and free spots, and also graph theory ensures faster routing compared to linear or manual search. You can use Google Maps or My India Maps. They use graph theory to show you shortest distances and all this. And coming to the next one, the advantages and innovations. What advantages I saw in using OOPS and this essentials for problem solving, and what are the new innovations I thought to my mind. I got to mind intelligent graph driven navigation inside the parkings, and also finds the nearest available spot instantly, and also fast exit routing reduces congestion, and also scalable to large malls, airports, smart cities, etc., and also integrates easy with IoT and AI prediction systems, makes much more easier. And also conclude, I want to conclude with the slide and which shows the entire hard work of me to solve this. That is, graph theory significantly enhances parking management efficiency. Automated systems improve user experience and reduces operational delays. Java plus object-oriented programming plus graph algorithms offer a modular, scalable solutions, future scope, and AI-based spot demand predictions, mobile app dynamic processing, and etc. Whatever the problems they may have, it clears in a single attempt. And um, thank you very much. Thank you for paying attention. Thank you, friends. The link or the PDF file for the this project report may be given in the description. Please check out there. Thank you, guys.